Hello, welcome to Calculus. I'm Quillen, and today I am going to be giving you some example problems to help you review the basic properties of limits that we discussed in yesterday's video. First, I want you to find this limit that I've written here. That is the limit of 4 as x approaches 3. Pause and take some time to do that now. All right, welcome back. I hope, and I apologize for the traffic outside. I hope you can still hear me well enough. All right, so the limit as x approaches 3 of 4 is 4. Let's talk a little bit about why that is. There is no x part in here, so x could be approaching infinity, x could be approaching Aleph 3, x could be approaching 0. It doesn't matter. 4 is 4 is 4. And if y equals 4, for example, then no matter what x is, the y value is going to be 4. I hope that makes sense. All right, here is your second example. I want you to find the limit of 2x squared as x approaches 5. All right, I hope you paused and found that the answer to that question is 50. Let's talk about why 50 is the answer. Well, unless there is a hole, and by hole, that's an informal way of saying discontinuity, which we have not covered yet. If there is a hole in the graph, then this does not apply. But if there is not a hole or break or discontinuity in the graph, then the limit of a function as x approaches a point is going to be the value of that function at that point. So in most cases, you can just plug in the x value for your x. So 5 squared is 25 times 2 is 50, and that's how we arrived at our answer. Here's your next example. I want you to find the limit of sine of 2x as x approaches infinity. All right, I hope that you found that this limit does not exist. Let's talk about why this limit doesn't exist. Well, this limit fails to exist because as sine of 2x goes to infinity, it's going to look like this. Even though that x does have a multiple, it's still going to be the curve is going to have the same shape. And it's just going to repeat with this sort of shape on and on and on. So when it gets to infinity, we don't know where in this period the curve is going to be. Therefore, the limit is inconclusive, and for that reason, it does not exist. Hello. Here is a problem set. All of these problems involve these two functions that I have described at the top. Again, I apologize for the potentially very loud traffic outside. So first, I want you to find the limit of the quantity f of x minus g of x as x approaches 1. All right, I hope that you found the limit in this way. So 4 minus 2x, we can pretty easily plug in that 4 minus 2 times 1 squared will be 4 minus 2. So this first will be 2. So from that, we're going to subtract over here, plug in 1 for x, so that's 3 over the quantity 4 times 1. 3 over 4 is just 3/4. So that means you can simplify your answer to 1 1/4 or 5/4, any of those, or you can just leave it like this. If you have an arithmetic or algebraic expression that can be simplified, but you don't have to use calculus to simplify it, then in most cases, you can just leave your answer as is. Next, find the limit of g of x times f of x as x approaches 2. All right, I hope you found the answer in the following manner. g of x, if we plug in 2 for x over here, we get 3 over 4 times 2, or 3 over 8. Then, for f of x, if you plug in 2, you get 4 minus the quantity 2 times 2 squared, 4 minus 2 times 4, 4 minus 8, negative 4. I will recommend simplifying multiplication, even if you don't simplify addition or subtraction, because it's just a very good habit to get into, and it is much easier. I'm so sorry for the traffic. I'll rewind a little bit. It is much easier, in my opinion, to simplify subtraction later on if you realize you need to than multiplication, because multiplication can get so big so fast. So I am going to write this answer as negative 3 over 2. And I am on a Chromebook, so the right clicks are accidental. And here's our final answer, negative 3 halves. Next, find the limit as x approaches 2 of g of 3 times f of x. All right, so I hope the first thing you did was find what g of 3 equals. So first you plug in 3 up here, and you can automatically see that 3 over 4 times 3 will cancel to simplify into 1 times 4, or 1 over 4, I should say. Then f of 2 up here is going to be the same as f of 2 down here. And so 1/4 times negative 4 is just going to equal negative 1. Although, again, you don't have to simplify if you don't want to. Next, find g of x over f of x plus 1, the limit as x approaches negative 4 of that expression. All right, I'm going to write out to the side instead of above for this one. So first plug in negative 4 for g of x, so that'll be negative 3 over 16. And I'm also going to rewrite the division as multiplication. Times, and because this is not a fraction, we know the numerator will be 1. We're plugging in negative 4. So 4 minus 2 times negative 4 squared. Negative 4 squared is 16. Twice that is 32. 4 minus 32 will be negative 28. And in all honesty, I don't want to simplify this, so I'm just going to write it as 3 over 16 times 28. And the great thing about calculus is you can do just that. If you simply don't want to simplify something because it would take too much time or your brain just hurts so bad, you can leave it at that as long as it's not a multiple choice question. Now find the limit of f of x to the negative 1 as x approaches 3. All right, so the way that I would solve this, and there's more than one way. I would solve this by first evaluating this inside part of the argument and then putting it in the denominator of a fraction, which is what a negative 1 power means. So just eyeballing this up here, 3 squared is 9, 2 times 9 is 18, 4 minus 18 is negative 14, so it will be negative 1 over 14. And that's our final answer. Lastly, I want you to find the limit as x approaches 2. This f should be lowercase right here. I just can't write with too much precision here. So I want you to find the limit of g of x raised to the f of 1 as x approaches 2. So first, let's evaluate f of 1. We actually already did that right here, but let's do it again just for fun. So you plug in 1 for x and square it. 2 times 1 squared is 2. 4 minus 2 is 2. So your power, I'm going to draw an arrow to signify I'm rewriting this out here. 2. Something is being squared. So now let's evaluate g of 2. 3 over 4 times 2 is the same as 3 over 8. And remember, the entire fraction is squared. And again, you can leave it here if you want to, but this is a pretty easy simplification. So this will be 9 over 64, and that is your final answer for this. All right, that will do it for today's video. I hope that you found these example problems helpful. I'm so glad that you have decided to continue with me on this journey through calculus, and I hope that you will join me again in tomorrow's video. This is Quillen, signing off.